Rosalind was born on July 25, 1920, into an affluent and influential Jewish family in London. Her upbringing was one of privilege, but it came with expectations. The Franklins were deeply involved in philanthropy and education, and there was an unspoken assumption that Rosalind would eventually follow the traditional path of many upper-class women: marriage, children, and a life of supporting her husband's career. But Rosalind had other plans. From a young age, she showed signs of a sharp intellect and a fierce independence. Rosalind was stubborn, even defiant, in the pursuit of her passion for science. While her family supported education, they struggled with her refusal to conform to societal norms. Her father, Ellis Franklin, who was himself highly educated and forward-thinking in many respects, didn't fully embrace her ambitions at first. He was hesitant about Rosalind pursuing higher education and a career, particularly in a field that was predominantly male. But Rosalind stood firm. By the time she was 9, she knew she wanted to be a scientist, and there was little anyone could do to change her mind. Attending St. Paul's Girls' School in London, a prestigious institution known for fostering academic excellence in young women, Rosalind flourished. She was particularly drawn to physics and chemistry, subjects that were at the time considered unfeminine. While her peers may have gravitated toward subjects like literature or the arts, Rosalind excelled in the sciences, and she was determined to make her mark. But even in this supportive environment, Rosalind would have been aware of the limitations imposed on women. It was the late 1930s, and while educational opportunities for women were growing, the professional world was still very much closed off. Science, especially, was a male-dominated realm where women were often relegated to lesser roles, even if they were equally qualified. Despite this, Rosalind continued to push forward, undeterred by the societal expectations that hovered over her. Rosalind's determination eventually led her to Newnham College, Cambridge, one of the few institutions that accepted women at the time. It was here that she furthered her studies in chemistry, though she quickly realized that being a woman in science would be an uphill battle. Even at Cambridge, one of the world's most prestigious universities, women were not treated as equals. They could attend lectures and conduct research, but they were not awarded full degrees until years later. For women like Rosalind, it was clear that they would have to work twice as hard for half the recognition. Yet, it was not only the academic world that presented challenges. During her time at Cambridge, World War II broke out, and Rosalind, like many young people, was called to contribute to the war effort. She took a break from her studies to work for the British Coal Utilization Research Association, conducting vital research on the properties of coal. It was a far cry from the molecular biology she would later become famous for, but it was during this time that Rosalind truly honed her skills in research. The war may have been a dark time for many, but for Rosalind, it was an opportunity. The chaos of war shifted societal norms, if only temporarily, allowing women like her to take on roles that would have otherwise been unavailable. Rosalind's work on coal helped improve its efficiency as a fuel, and her research earned her a PhD from Cambridge. While many men were away at war, Rosalind proved that she could excel in her field, quietly breaking down barriers. Paris, the first taste of freedom. After the war, Rosalind moved to Paris in 1947 to work with Jacques Meringue, a pioneer in X-ray crystallography, at the Laboratoire Central de Services Chimiques de l'État. This was a turning point in her career, not just professionally, but personally. In Paris, Rosalind found a scientific community that respected her for her intellect and contributions, regardless of her gender. For the first time, she experienced what it felt like to work as an equal among her peers. Her time in Paris was marked by a newfound confidence. She became an expert in X-ray crystallography, a technique that would later prove crucial in her work on DNA. More importantly, Paris was a place where she was no longer constantly reminded of her gender. In London and Cambridge, being a woman in science was an anomaly. In Paris, she was simply a scientist. Yet, while her professional life blossomed, Rosalind remained deeply private. She never married, never had children, and kept her personal life out of the public eye. It wasn't that she didn't want a family. By all accounts, she had close relationships with her parents and siblings, but science was her great passion, and she wasn't willing to compromise on that. She poured her energy into her research, driven by a sense of purpose that few could match. King's College London, the DNA struggle. In 1951, Rosalind returned to London to work at King's College. Here, she was assigned to study the structure of DNA using X-ray crystallography. What should have been a groundbreaking opportunity soon turned into a source of frustration and conflict. The environment at King's was far from the egalitarian atmosphere she had enjoyed in Paris. Rosalind was working alongside Maurice Wilkins, but their relationship was fraught with tension from the start. Wilkins, a senior scientist, initially thought Rosalind had been hired as his assistant, a misunderstanding that set the tone for their strained collaboration. Rosalind, however, was not the type to play second fiddle. She was brilliant, focused, and unwilling to let anyone, male or female, diminish her role. The lab was a boys' club, and Rosalind was seen as an outsider, a woman who didn't fit in with the easy camaraderie of her male colleagues. Despite these challenges, Rosalind produced some of the most important data on the structure of DNA, including the now famous Photo 51. This image provided crucial evidence of DNA's double helix structure, a discovery that would later revolutionize the field of molecular biology. Yet, even as she inched closer to a breakthrough, Rosalind was being undermined. Without her knowledge, her colleague Maurice Wilkins shared her findings with James Watson and Francis Crick at Cambridge. Using her data, Watson and Crick were able to build a model of DNA's structure, publishing their results in 1953. Rosalind's contribution was acknowledged in passing, but it was Watson, Crick, and Wilkins who would go on to receive the Nobel Prize in 1962. Rosalind, who had died of ovarian cancer in 1958, was never recognized for her pivotal role. Overcoming the odds, a legacy unfulfilled yet eternal. Rosalind Franklin's life was cut tragically short at the age of 37. But in those few short years, she made contributions to science that continue to resonate today. She worked tirelessly, often in environments that were hostile or dismissive of her talents, but she never gave up. Even when faced with exclusion, she chose to focus on the work that mattered to her. Her story is one of overcoming, not in a loud, defiant way, but with quiet resilience. Rosalind didn't seek recognition, but her work spoke for itself. She didn't fight for attention, yet history has begun to correct its oversight. Today, Rosalind Franklin is remembered not just for the injustice she faced, but for the incredible legacy she left behind. In the end, Rosalind's greatest victory wasn't winning a Nobel Prize or having her name in headlines. It was in proving that brilliance knows no gender. Her work on DNA, viruses, and X-ray crystallography has shaped modern science, and her story serves as a beacon for women in STEM fields, showing that determination, intellect, and passion can break down even the most entrenched barriers.